Hello and welcome to Solutions. This is the 5th episode of our second series of podcasts for solution-focused hypnotherapists. I'm Kathy Eland.
And I'm Trevor Eddolls, and we're both experienced solution-focused hypnotherapists.
Today we're looking at the brain, trance and EEGs.
Yeah, the brain is 3 pounds of neurons, glial cells and cerebrospinal fluid that's divided up into lobes. And if you like numbers, it's estimated that there are 128 million neurons plus 69 million glial cells. At the front of the brain is the frontal lobe, which is used for movement, intelligence, reasoning, behavior, memory, personality, planning, decision-making, judgment, inhibition, and mood.
Wow.
The occipital lobe is right at the back and is used for the understanding of visual images and understanding written words. At the top, in between these two lobes, is the parietal lobe, which processes sensory information it receives from the outside world, mainly relating to touch, taste, and temperature. And across the bottom is the temporal lobe. It looks like your thumb if you're making a fist to model the brain when showing clients. It's responsible for speech, behavior, memory, hearing, vision, smell, and emotions.
Okay, interesting. So shall we move on to trance?
Yes, so when a person is in trance, they generally feel a deep state of relaxation. Some say that they have a feeling of altered awareness, and they often experience a sensation of drifting or floating.
Yeah, and Paul Dell in 2017 suggested that hypnotic responding is a neurobiologically rooted, genetically inherited ability of the human brain to shift, knowingly or unknowingly, to a motivated mode of neural functioning that enables most humans to alter, to varying degrees, their experience of body, self, actions, and world.
Yes, but he then complains about much of the research that's been done by saying that in academic literature, the word hypnosis has come to mean heterohypnosis.
Okay.
This can be defined as a hypnotic state that is created by another person, including by listening to CDs or downloads. This is different to self-hypnosis, which is a hypnotic state that is self-created. In addition, Dell suggests that the therapist-induced state takes place within a specific context, e.g. a treatment room, and that requires a specific kinetic change, i.e. on the couch. Because people can, to a varying degree, enter a hypnotic state without needing a therapist, Dell goes on to argue that the presence of a hypnotist and the heterohypnosis context are therefore merely convenient environmental stimuli for facilitating the person's activation of this ancient mode of neural functioning.
Okay, so what you're saying is that Dell is arguing that research into hypnosis really never gets to the essence of hypnosis, but is focused on heterohypnosis situations. He asserts that we need to investigate and understand hypnosis as a mode of spontaneous self-hypnosis. Anyway, whatever the type of hypnotherapy used, Bazzelli et al. In 2017 found that hypnosis reduced the heart rate, reduced the respiration rate, and decreased the nociception response, which, they concluded, was by acting on the parasympathetic nervous system, producing a calming effect on the body, reducing anxiety and the fearful state. So that's got to be good.
Yes, and to save you looking it up, nociception is nerve cells detecting or receiving painful or noxious stimuli. Sell et al., also in 2017, found that hypnotherapy significantly reduced distress in psychiatric outpatients.
So we can conclude that hypnotherapy has positive benefits.
Yeah. So let's move on. One way to see that something is happening in the brain is to use brainwaves, or EEGs, which stands for ElectroEncephaloGrams. Lots of electrodes placed along the scalp record electrical activity on the scalp, which represents the macroscopic activity of the surface layer of the brain underneath. This is electroencephalograms. ElectroEncephalography, and the graphs it produces are the ElectroEncephalograms. The electrodes actually measure voltage fluctuations. As you know, neurons are connected to each other across synapses, which acts as gateways of inhibitory or excitatory activity. Any synaptic activity generates a subtle electrical impulse, which is called a postsynaptic potential. One of these is very hard to detect, but when thousands of neurons fire in sync, they generate an electrical field that's strong enough to spread through tissue, bone, and skull. And that's what can be measured on the head surface. The neural oscillations in the frequency of the encephalograms are what people call brainwaves. And different types of brainwaves can be observed at different times, depending on what the brain is doing.
Yeah, so brainwaves of different frequencies, and these are measured in hertz or cycles per second, are given different names. And these are alpha, 8 to 12 hertz, where you're awake but relaxed, which is good for meditating and self-hypnosis. Beta, which is 13 to 30 hertz, and that's when you're wide awake. Theta, between 4 and 8 hertz, light sleep or extreme relaxation, and this is a good state for hypnosis. And finally, delta, which is 1 to 4 hertz, found in dreamless sleep, and delta is the slowest band of brain waves. There are also mu waves, 8 to 13 hertz, and gamma waves, 30 to 150 hertz.
Yeah, and the normal EEG varies with age. A neonatal EEG is quite different from the adult EEG. The EEG of a child usually has a lower frequency than the EEG of an adult.
Anyone who's ever looked at an EEG will have seen that different brainwaves can be present at the same time, and it's the dominant frequency from the EEG that is used to name the current brain state. So if lots of beta waves can be seen, then the brain is said to be in a beta state, although there are others there, just to a lesser extent. There is no gamma state of mind because gamma waves largely play a supporting role in the brain. Brainwave patterns change in a gradual way during the day and on entering hypnosis.
Yeah, a client is probably in a mainly beta wave state at the start of a hypnotherapy session. That's the alert focus state. As the client allows themselves to relax, they will enter an alpha wave state. The value of using a deepener is to take the client down to a theta wave state. This is thought to be like stage 1 of sleep. At this level, trance can be very effective in helping a client make positive change. Some clients will enter a deeper level of trance, what some people call a somnambulistic trance, where the dominant brainwave state is delta. In this state, clients could open their eyes without affecting their state of trance.
So do different lobes of the brain on different hemispheres produce different brain waves? That's what Graffin et al. In 1995 and Ray in 1997 looked at. They recorded alpha, beta, and theta activity separately from frontal, temporal, parietal, and occipital sites of both left and right hemispheres of the brain. They also compared male and female subjects and susceptible and unsusceptible subjects. What they found were more theta waves in hypnotizable compared to unsusceptible subjects, especially in frontal and temporal areas. Hypnotizable subjects showed greater resting alpha activity only in the temporal area. The induction of hypnosis decreased theta activity in hypnotizable subjects, while increasing it among unsusceptible ones, particularly in parietal and occipital areas. Alpha activity generally increased across all parts of the brain.
Yeah, Sabarin et al. In 1990 found that people highly susceptible to trance had more beta activity in the left than right hemispheres, while low susceptible subjects showed only weak asymmetry.
Okay, and interestingly, a 2016 study by Stanford University's David Spiegel and colleagues discovered 3 hallmarks of the brain under hypnosis. although each change was seen only in highly hypnotizable people undergoing hypnosis. The changes were a decrease in activity in the dorsal anterior cingulate, an increase in connections between the dorsal lateral prefrontal cortex and the insula, a reduction in the connections between the dorsal lateral prefrontal cortex and the default mode network, which includes the medial prefrontal and the posterior cingulate cortex.
Interesting. The history of EEG is also quite interesting. The very first published findings were in 1875 by Richard Caton following his open brain experiments on animals. In 1890, Adolf Beck demonstrated the existence of brainwaves. In the 1920s, human brainwaves were detected, and the first recordings were made by Hans Berger in 1924. More complex EEG measurements became possible in the 1950s, and William Gray Walter produced the first electrical map of the brain. He found that alpha waves originated from the occipital lobe of the brain, the part of the back.
So it's interesting to see that no one seems to have a clear idea of what hypnosis or trance actually is. And research seems to have a problem separating different ways that trance can be induced. In addition, most studies seem to distinguish between people who can be hypnotized and those who can't. While most hypnotherapists I know don't make that distinction, but some research seems to involve wiring people up and seeing what happens. Other research seems to try to actually test a hypothesis, and much research seems to involve lots of categories of subject without having large numbers of people in each category. Clearly, a lot more research is needed.
Indeed. But what we can see is that dominant brainwave patterns change as people go into trance, which is interesting in itself.
Yeah, it is. Well, that's about it from us. Next time, which will be in August, we'll be looking at the anterior cingulate. So it's goodbye from me, Kathy Eland.
And it's goodbye from me, Trevor Eddolls.
See you next time.
Yeah, bye.
Bye.